Hello everyone. So in this video we'll look at how to find adjoint of a matrix. Now let me take a 3x3 matrix. A is equal to E11, E12, E13, E21, E22, E23, E31, E33, E32, E33. So here this is a general matrix. When we say E11, it means that the first number represents row and the second number represents column. So here when I say E11, it is an element in the first row, first column. It's an element in the second row, first row, second column, and element in the first row, third column. Similarly, it is element in the second row, first column, element in the second row, second column, and element in the second row, third column, and it goes on. Now, in order to find adjoint of this given matrix, so we represent adjoint by adj of A. That means adjoint of A. Now, adjoint of any matrix is a matrix found by replacing, is a matrix or the transpose of the matrix found by replacing each element by their respective cofactors. Now, cofactors let me represent by capital 1, capital A. So E11 means cofactor of the first element, E12, E13, E21, E22, E23, E31, E32, E33, and take its transpose, then you will get the adjoint of the given matrix. So that is A11. Transpose means we are interchanging rows and columns. So here in the first matrix, when you see here, this is the row. Now if you write that row in the column, then that is what is meant by changing rows and columns. So A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the adjoint of the given matrix. Now let me explain this concept by taking an example. For example, let me take a 3x3 matrix. A is equal to 1, -1, 2, 2, 3, 5, -2, 0, 1. Now, to find the adjoint of this matrix, adjoint of A is equal to, first always try to write this general general adjoint. So that is, write A11, A12, A13, A21, A22, A23, A31, A32, A33. In this case, I forgot to mention one thing. So here you have to know the signs of each of these elements beforehand. That is, if the sum of these two numbers is positive, the sum of these two numbers is even, then the sign is positive. If the sum of these two numbers is odd, then the sign is negative. Or if this is positive, the another one is negative. We have to take the alternative signs. So this is positive, this is negative, this is positive, negative, positive, negative, positive. Now, let's find the adjoint of this given matrix. So here, simply what you have to do is, in order to find the adjoint of this matrix, so adjoint of A is equal to, so here I'm taking a small letter. I think taking a small letter is more convenient to represent the adjoint. So here, in order to find the cofactor, we are saying that this capital E11 is the cofactor of small e11, isn't it? So we have to find the cofactor of this element. Now, in order to find the cofactor of that element, what you have to do is you just delete this column and this rows and find the determinant of the remaining elements. So that is 3 times 1 is 3 minus 0 times 5 is 0. So here the cofactor of the first element is 3 and the sign is already positive. Right? Now find the cofactor of the second element, that is E1, 2. In order to do that one, what you have to do is you delete this column and this row and find the determinant of the remaining elements. So 2 times 1 is 2. Negative 2 times 5 is negative 5. So it is 2 plus 5. So, sorry, 2 plus 10, right? Negative 2 times 5 is negative 10. So 2 plus 10 is 12. So here you have to write 12. We got positive, but due to the sign at 12, it is negative. Now, third one, the cofactor of E1, 3 is this one. Right? You have to find this element. So this one, what you have to do is you delete this column and this row and find the determinant of the remaining elements. 2 times 0 is 0 plus 6 is 6. So here it is 6 and the sign is already positive. So here also it is positive. Now quickly let's look at the cofactor of this element. In order to find the cofactor of that element, we have to delete this row and this column and find the determinant of the remaining elements. So negative 1 times 1 is negative 1, minus 0 is negative 1. So here it is negative 1. But already we have negative out here. Due to that one, the cofactor out here is positive 1. Again, find the cofactor of this element. In order to find the cofactor of that element, delete this column and this row and find the determinant of the remaining elements. So 1 times 1 is 1 plus 10 is 12. 1 times 1 is 1 plus 10 is 11, not 12. Okay. So here, well, where do you have to write? Okay, wait. So we delete this row and this column, isn't it? So here 1 times 1 is 1. Then negative 2 times 5. Not this one, negative. So we have to do negative 2 times 2. That is 4. So it is plus 4. So our answer here should be 5. Positive 5. So sign is also positive. So answer is positive 5. Now let's find the cofactor of this element. In order to find the cofactor of that element, we delete this column and this row. So 1 times 0 is 0. Negative 2 times negative 1 is positive 2. So it is negative 2. And already we have the sign negative. So that's why we have to write here positive 2. Hope it is clear. Now, next, let's find the cofactor of this element. In order to find the cofactor of that element, what you have to do is, let me use this color to find. So you delete this row and this column and find the determinant of the remaining elements. So negative 1 times 5 is negative 5, minus 6 is negative 11. So here as such we get negative 11, and since the sign is positive, so the cofactor still remains negative. So it is negative 11. Similarly, if you find the cofactor of this element, you will get that cofactor as a negative 1. And to find the cofactor of this element, you will get the cofactor as a 5. This is for you to try yourself. So that's it. So this is the adjoint of a 3 by 3 matrix. Now, if you are given with a 2 by 2 matrix, it is very simple. 2 by 2 matrix. So for example, 2 by 2 matrix, 2, 1, 4, negative 1. This is a 2 by 2 matrix. if you're asked to find the adjoint of this matrix, so let me take this matrix as B. So matrix B. Okay. So matrix B. So adjoint of B is equal to. So here, what you have to do is you simply have to interchange the elements in the leading diagonal. This diagonal is known as leading diagonal. Okay? Just interchange the elements in the leading diagonal. So here, -1, then 2, and simply change the sign of the other diagonal. Change the signs of the other diagonal. Okay? So that is, this will become -4, and this will become -1. That's it for 2 by 2 matrix. Hope it is clear. This works only for 2 by 2 matrix. Hope everything is clear here. Just go through everything once again. It's very simple. So you should know the definition of adjoint of a matrix. It's a matrix formed by taking transpose of a matrix when each element of the given matrix is replaced by their respective cofactors. Fine? And you should know how to find the cofactors of a matrix. So first step, whenever you find the adjoint of a matrix, just try to write this with sign. You should know the signs. Okay? Then it's simple. Find the cofactors of each of the elements, fill it out, and there you are. Thank you.